Have you ever wondered how macros in assembly language work, what they are and why they're used? Let's unravel this mystery together. At the heart of assembly language programming, we find macros. They are like the secret sauce that adds flavor to the code by allowing us to define and reuse code snippets. Think of them as a form of text substitution that facilitates code generation. Imagine you're writing a lengthy novel, and there's a phrase you find yourself repeatedly using. Instead of typing it out each time, you create a shortcut, a macro, to represent that phrase. You write it once, and then you use your shortcut to represent it throughout your novel. In the world of programming, this idea is the same. Macros provide shorthand notations for sequences of instructions or expressions that are used repetitively. So, in essence, macros allow you to write code once and use it many times over. Now, how do you go about defining a macro in assembly language? Well, the first step to defining a macro is to declare it using the macro keyword. This is followed by the name of the macro and a set of parameters. These parameters act as placeholders for values you will provide when invoking the macro. Imagine you're creating a macro named MyMacro. Your declaration would look something like this: MyMacro MACRO param1, param2. Following this declaration, you would then provide the instructions for the macro, using param1 and param2 as placeholders. Here's a more concrete example. Let's say we're creating a macro, MyAddition, to add two numbers together. The declaration would look like this: MyAddition macro operand 1 operand 2. Then comes the meat of the macro, the instructions. In assembly language, to add two numbers, you would move the first operand to a register, say AX, and then add the second operand to AX. So the instructions for our MyAddition macro would be movax operand 1 and addax operand 2. But we're not done yet. After defining the instructions, you need to end the macro definition with the ENDM keyword. So the complete definition of our MyAddition macro would look like this: MyAddition macro operand 1 operand 2 ENDM. This macro is now ready to be used or invoked in your code. Macros are a powerful tool in your assembly language programming toolkit. They can simplify your code by encapsulating repetitive sequences of instructions or expressions. They allow you to write more maintainable, readable, and reusable code. But like all powerful tools, they need to be used with care and understanding. And that's how a basic macro definition looks like. But how do we use it? Stay tuned to find out in the next scene. We've defined our macro, but how do we actually put it to use? Well, invoking a macro is pretty straightforward. You simply use its name followed by the actual parameters. Let's bring back our previous example. We defined a macro called sum_macro that takes two operands and adds them together. To invoke this macro, we write sum_macro and then provide the values we want to add. So if we want to add 5 and 7, we'd write sum_macro 5 7. When the assembler encounters this line, it substitutes the macro invocation with the actual code defined in the macro, replacing the parameters with the values we provided. In this case, it becomes movax 5 addax 7. It's like magic, isn't it? We've written a piece of code once, and now we can use it anywhere in our program just by invoking the macro with the right parameters. So, by invoking the macro like this, we're able to reuse our defined code. Macros aren't just limited to simple code snippets, though. They can get quite complex. Let's dive into the world of conditional macros and looping macros. These are advanced concepts that allow for more dynamic and flexible code generation. A conditional macro is a macro that includes conditional statements based on parameters. Think of these as macros with a built-in if statement. For instance, here's an example of a conditional macro. Imagine a macro named print_if_positive. This macro checks if a value is greater than 0. If it is, the value is moved to the AX register, and then we have some code to print the positive value. This macro can be really handy when you want to filter out and print only positive values from a list. Next, we have looping macros. Looping macros are macros that repeat a set of instructions a certain number of times. This is a form of code generation, where the macro generates repetitive code sequences based on a specified loop count. Consider a macro named repeat_10_times. This macro uses the rept assembly directive to repeat a block of code 10 times. The beauty of this macro is that the code block to be repeated can be anything you want, from performing arithmetic operations to moving data around. Now you might be thinking, wow, macros seem really powerful. And you're right, they can be. Macros allow you to write code that's easier to read and maintain. They help you avoid repetition, reduce errors, and save time. But, like any powerful tool, they must be used with care. macros perform text substitution, which can sometimes lead to unexpected results if not used carefully. For example, if a macro parameter is an expression rather than a single value, the expression might be evaluated more than once, leading to unexpected behavior. Additionally, debugging code that involves macros can be challenging. This is because the debugger doesn't see the macro, it only sees the expanded code. So, if there's a bug in the macro, it can be difficult to trace back to the source. Finally, it's worth noting that while macros can be quite expressive, they're not as expressive as high-level programming constructs. Their use is often limited to simple code generation tasks. For more complex tasks, you might need to resort to functions or other programming constructs. Remember, the goal is not to use macros for everything, but to use them where they make sense, where they make your code cleaner, more efficient, and easier to maintain. As you can see, macros can be quite powerful and versatile, but they must be used with care. Like any tool, macros have their guidelines and limitations. They are a powerful asset in a programmer's toolbox, but they require a keen understanding and careful handling to be used effectively. Firstly, one of the key guidelines for using macros is to design them with code reusability in mind. Macros should be written in a way that they can be reused across different parts of your program. This not only saves time, but also ensures consistency in your code. Secondly, parameterization is a key aspect of effective macro usage. Parameters allow macros to be flexible and adaptable to different situations. They act as placeholders for values provided when the macro is invoked, making the macro more versatile. Documentation, as always, is crucial. Macros should be clearly documented, describing their purpose and usage. This is particularly important as macros can often be complex and challenging to understand without appropriate context or explanation. A well-documented macro is one that can be used correctly and effectively by other programmers. Finally, be mindful of the code that your macros generate. It's important to ensure that the expanded macro code is both efficient and correct. Remember, macros perform a form of text substitution, and this can sometimes lead to unexpected results. And that brings us to the limitations of macros. Macros perform text substitution, which can lead to issues if not used carefully. For example, a macro might introduce unwanted side effects or unexpected behavior if it's not designed properly. Also, macros aren't as expressive as high-level programming constructs. Their use is often limited to simple code generation tasks. They lack the features of high-level languages such as object-oriented programming, exception handling, and so on. Lastly, debugging code that involves macros can be challenging. This is because, with macros, you're often dealing with the macro definition rather than the expanded code. This lack of direct visibility into the expanded code can make it difficult to identify and fix issues. In spite of these limitations, macros remain a valuable tool in assembly language programming when used correctly. Macros in assembly language, then, are a powerful tool for code generation and reusability. They offer a shorthand notation for repetitive instructions, saving time and promoting consistency in your code. Remember how we defined macros using the macro keyword, and invoked them by simply writing their name followed by the actual parameters. We also delved into more advanced concepts, showing how macros can include conditional statements and loops, making them adaptable to a variety of scenarios. And of course, we discussed the importance of designing reusable macros, documenting their purpose and usage, and being mindful of the code they generate. However, it's crucial to remember macros do have their limitations. They perform text substitution, which can lead to unexpected results, and they're not as expressive as high-level programming constructs. Debugging macros can also be a challenge. And that wraps up our exploration of macros in assembly language. Remember, the key to mastering macros, like any programming concept, lies in practice and exploration. So don't shy away from getting your hands dirty.